looking? Oh, haha. I haven't set up the YouTube for this yet. Okay, so all the details on this YouTube are going to be wrong. Hey everybody, Smitty here. I've got about 15 to 20 minutes before I need to leave the house and head off somewhere, but I've got a little tiny project that I want to do that I wanted to share with you guys, with you all. And for starters, new camera, higher frame rate in theory. We'll see whether it actually works out that way or not. But I don't have a lot of time, so I'm just going to go into it. This is my first video in quite a while, or at least this kind of video. I apologize. My life has been crazy for the last several months. Just a lot of personal stuff going on. Not bad, just busy, real busy. I've been doing daughter's ballet. We had a lot of family activities going on, travel for work and for personal and stuff like that. So just wild and crazy stuff. We're not done yet, but we're getting close to that. Hopefully late December and kind of January I can start doing this kind of stuff a little bit more often. But right now we're going to throw out a quickie because I can. So real quick description of what the project is. Double Cross, a NOAA satellite downlink antenna. So some friends of mine have been getting into kind of satellite work, and I tried receiving some APRS downlinks from the ISS on my vertical antenna up on the roof, but apparently its gain is too high and its radiation pattern is too flat, and I never received anything. So I want to try building an antenna that would be better for working satellites, and that's exactly what this antenna is. This antenna this article was originally published in QST. I don't remember when. It's probably labeled down at the bottom of one of these pages, February 2008 in QST. But you can find the article here, and I'll stick the link in the notes, but it's qsl.net/py4z/DCA.pdf, doublecrossantenna.pdf. So I've already built most of this stuff here. I constructed it a little bit differently than they have it in the article, but conceptually it's all there. The part that I have not yet done is the wiring and the phasing of the antenna. So you've got 4 different dipoles that are phased in interesting ways. Dipole 1 and 2 are across from each other, and 3 and 4 are across from each other. So what you're doing is you're putting dipoles 1 and 2 in series. So you'll notice that it comes up here, the center conductor goes up, out of the shield gets connected to that one, and the center conductor down here. They're in series, but they're also 180 degrees out of phase. The signal comes in on the center, out on the outer, back up on the outer, and back in on the center. So they're reversed from each other. They're not in parallel, they're in series. And by doing it in series like this, you make basically 100 ohm. 250 ohms in series makes 100 ohm. And then you've got the other 2 antennas that are hooked up exactly the same way. 250 ohms in series makes 100 ohm. And then you take this 100 ohm and that 100 ohm and put them in parallel, and you get another 50 ohms in parallel now. And so that's how you match 4 50 ohm antennas to your 50 ohm coax. The standard way of doing this is just get all of the coaxes, cut them, split them, and like solder them together in a giant blob, and somehow that doesn't really appeal to me. What I want to do is I want to put SMA connectors on all of these, including the input, and then just have a little tiny board with the SMA connectors on it that will do all of the proper phasing in parallels and perpendiculars and series and all that fun stuff. So that's what I'm going to work on today. So I've created, here we are, we have an empty KiCad, and let's just throw down, we got what? That's not what I expected. Okay, well, let's go look for it then. Connect. Oh, come on. Anyway, we're going to go find an SMA connector. Or was it coax? BNC, that's the one I've been using. It'll do. It just needs to be a 2-pin connector. So we're going to zoom in, and we are going to throw down several of these. And then, oops. Copy, and we'll flip that around the y-axis for our input, and we'll do that. Okay. So let's see here. Input here goes to the input on that one. Output of this one. well, not really inputs and outputs, but we'll do it this way. All right, so that's one of my things. And then we come along and do the same thing on the other one. Okay, that's the schematic. Simple, easy. Center conductor goes up to the center, shield goes to shield, center goes to shield. Same thing here. Center goes to center, shield to shield, and then center to shield. Yep, so that's our schematic. That was quick and easy. Let's annotate. Yoink. So we got what? There we go. 1, 2, 3, 4, 5. Okay. Let's actually name these value. ant1, value ant2, value ant3, value ant4, and value input. Okay. That was that. Let's go put some connectors to these, and this is where the SMA is. Connectors. Oh, wait, nope. I have defined my own. Libraries. SMA vertical or edge. Let me show you what this looks like. Ooh, bring you over here. That's too big. So this is an outline that will take either a vertical SMA sticking straight out of the board or an edge mount SMA. It's kind of my standard SMA connector to use at this point. So we're going to go grab that. And all of those are that. Save that. Go away. And then, oops, hang on. I got to save a netlist first. Okay, now I can open up my schematic. And then I do import netlist, read netlist. Yay, that was easy. Hey, look, a bunch of connectors. Okay. So the way I want this to work is this is all going to be in a 1.5 or 2 inch. I think it's a 2-inch piece of 2-inch PVC. So I'm going to have a long, skinny board that's going to go vertically through the coax, and I'm going to have the input on the bottom edge connector, and then I'm going to have the two longer. Oh, let's go back and discuss that really quickly. Notice here how 2 of these are the same length. Doesn't matter what the length is as long as they're the same. And then the other 2 are the same plus a quarter wave longer. So what you're doing is these are actually 180 out of phase the way that you're wiring it up here. And these are 180 out of phase. But these 180 are an additional 90 degrees out of phase from that, an additional quarter wavelength. So basically this one's in phase. Let's see here. How does it work? This one's in phase. This one is 90 degrees. That one's 180. That one's 270. And so you end up having these 4 different antennas that are all 90 degrees out of phase from each other. That's what we're going for here. But you'll note that 2 of these have longer pieces of coax by about a quarter of a wave. So I want the 2 with longer coax pointing down because the coax is going to come down the PVC. It's going to pass this board. It's going to circle around and come back up and connect to the bottom of the board. Similarly, the input coax is going to come up and connect to the bottom of the board. And then the 2 shorter pieces of coax will just go straight up. So I want antenna 1 and antenna 2 pointed upward. It's going to go down. Rotate up. And then antenna 3 and antenna 4 will go like that. And then the input, aesthetically, I like having the input in the center, but that's going to make it hard to route. So I think I'm going to put the antenna off to the side. And these need to be spaced out enough that I can screw on a connector. So let me go figure out what that spacing is. I happen to have a whole bunch of crap on my desk that's falling. Hey, Get out of there. There we go. I happen to have an SMA connector on my desk. Oh, shoot. Haha. You can tell I'm a little out of practice. I have been showing you me, not my desktop. My apologies. So I wanted to have the input over here, and then the antennas 3 and 4, which are the long ones, pointing down, and then antennas 1 and 2 pointing up. But now let me go back to me. It's been a while since I've done video switching. So my handy-dandy calipers, if you don't have calipers, these things are awesome. I'm currently doing inches, so let me go to inches and 0 it. All right, so there's my calipers. They're all zeroed out. I want to measure the longest diagonal of this SMA connector because that is what I want to use, then some, as my minimum spacing. So hopefully you can see what I'm doing. I'm trying to kind of hold it at the diagonal and measure it at the diagonal, and it is measuring 0.3485. So I'm going to round that up to 0.35, and actually probably space them out at 0.4 inches, just to give myself some extra breathing room. All right, so if this is going to be antenna 3 is going to be the center of the board, what is that? Let's move that to an even number. Is that 0.7? So let's move that over to 0.6, or 6.0. Okay, so what I did is I just moved the center of this connector right here down to the dimension the x dimension right here is 6.0, so that I can easily space the other things. So if I want it to be 0.4 inches over, I need to move the center of this over to 0.4, or at least no closer than that. And maybe, let's see here. Let me go measure my 2-inch PVC. Stand by. Okay. It's on. It's zeroed. What is the maximum horizontal space I'll have here? Looks like 1.6 inches is the internal dimensions on my PVC. So long as I keep the total board dimensions to be less than 1.6 inches, and it'll probably be closer to 1.5 just to make sure I've got the space. So if I space these at 1/2 inch like that, it'll be 1/2 inch from here to here and 1/2 inch from here to here. That's 1. And then, yeah, that'll probably be just about right. So I want this to be at 5.5 or 4. Nope, right there. Okay. And footprint. And we'll just center these. Is there a center? 2, 3, 4, 5, 6, 7. Yep. So that would be the center. Okay. Yep. All right. Now we can move them closer if we want. Let's move these off the edge of the board. Let's draw our edge cuts and see how big this actually is. So that's 5.325. 5.325 to 6.675. So that's less than 1.5 inches, because 5.325 plus 1.5 would be 6.825. So as long as this is less than 6.825, it is. So we're less than 1.5 inches wide, which is good. So let's go with this. Link. And the vertical space here is somewhat arbitrary. Boink. Okay. There's our board. So 1 and 2. Wait a minute. How did that do that right? So 1 and 2. Oh, yeah, that makes sense. Okay. So let's start out with a ground pour. Nope, that's a keep out. That's not what I need. I want that one. Warning, zone display is off. Okay, we'll fix that. Cancel. Top. Okay. Top. Oh. I never actually labeled them. Ha ha ha. Well, I'm pretty sure pad 1 is ground. Let's check that. Whoa. Okay. B. Why aren't you drawing? No. 2 is ground. It's not what I want to do. Or do I? I want P1 pad 2. Edit. Zone outline. I want it to be P1 pad 2. That's the one I want. There we go. And it doesn't actually connect to any of them? Really? Huh. Okay. Well, let's put one on the ground as well, because that is our proper ground. P1 pad 2. This may not be as useful as I think it will be, but we're going to give it a shot anyway. See, why are you not connecting to that one? I think my outline, my component outline has some issues. Okay, so we got, that's our proper ground pour. Let's see here. Where does this one go? Nope. First off, let's go to top and design rules. I want much wider tracks. 0.025? 20. Let's see what that does. Do-do-do. Trying to figure out how best to split that out, because that's going to give me a less than 90. Can I do it from here? Okay. So I don't want that one. I want that. And then I want that to connect right there. And that to connect right there. Because that's going to fill into the ground. So if I do that and B, what we actually have on the top is that. And I think that's what we want. So I've got in, going into the center there, the shield going to the shield, and then the center there going to the ground. And that happens on both sides, except for the fact that that top ground is completely disconnected. Although it won't. No, it is. So I'm going to drop some vias from here to the bottom layer, because if I do that, that's a solid one. That's how those are connecting. And so I want to via this ground plane pour to the other ones. So that's connecting the top and the bottom. Why isn't that one going in? These outlines of mine definitely have some issues, and I'm not sure what they are. Like the fact that it doesn't want to use that. Okay. Oh, I'm on the bottom. I can actually connect him left to right, too, can't I? Ha ha ha. And okay. So that connects to that all the way around. That connects to that all the way around. So those are in series now. I got some vias to drop. Okay. Let's just start stitching. So if I remember. And I've got to get moving, head out for the day, but let me finish stitching. Come on. All right. Come on. That's good enough. Okay. And I need to do it from here so that it's attached to the right node. Well, that's kind of a pain in the butt. Unless I do it this way. There we go. So KiCad developers, I love your product. I really do. If you're looking for any ideas of features to add, an automatic stitch mechanism would be kind of nice. Okay. That looks pretty good to me. Let's do a DRC. Design rule check. Everything's connected, no problems. Save that. And let's go here. See if I can do this without showing anything of mine that you shouldn't be seeing. I don't have any text on here, but I think I'm okay with that for today. Oh. Nope. All right, I'm going to end it here because I need to get moving. But I will just go add some text to that page because I do want to mark which one is the input. Anyway, thanks for joining me. This was a quickie. Not doing anything else today. Haven't even updated YouTube for this live stream, so I'm sure YouTube is telling you I'm streaming about something completely unrelated. Sorry about that. Thanks for watching. I'm Smitty Halibut. Catch me on Twitter at SmittyHalibut. And tell me what you think. Tell me if you're ever going to build or have built a double cross antenna yourself, and let me know. Thank you so much for watching. Be good humans. Chat with you later. Waiting for the stream to show, even though I'm not watching my stream anywhere, so I don't really know, but I'm going to hit stop now. Bye.